Hello everyone, welcome to lecture number 11 of Applied IoT. Uh, so in this today we are to start with interoperability as a property of or the capabilities of IoT system when designing a IoT architecture. In the last lecture, we talked about scalability, but before coming into the current topic, as usual, um, we will look at what we have learned so far, right? So, if you go to the very first, what we learned so far is first we understood what is IoT, right? The Internet of Things describes the network of physical objects or things that are embedded sensors, actuators, processing ability software, and other technologies for the purpose of connecting and exchanging data with other devices and systems. So that is a basic definition of IoT. Then we identified or look at examples to understand what are IoT devices, right? Here in this, from the definition itself, you can see that sensors, actuators, and processing ability, alongside with compatible software, is are the parts of IoT device. So, for examples, we talked about cameras, smart lights, temperature control, motion detectors to smart plugs or smoke detectors. We talked about industrial scale robotic arms, smart locks, smart hospitals, health monitoring devices, autonomous driving, weather monitoring, and so on and so forth. We talked about these things. Then we looked at examples how IoT devices can be used, or the data that is being produced by IoT devices can be applied in real world applications. Our first example was a very simple one where we take real time weather data and adjust our temperatures again through IoT automation in a smart home or a building, either by increasing increasing the air conditioning or increasing the heating, depending on if it is winter conditions or summer conditions, or depending on the location. Then we talked about how a set of IoT devices or a set of IoT devices making entire IoT system where it is used to tackle fire situations, fire breaking out in uh, buildings. We followed that up by using the data of uh, using real-time data and predictions, which we come across through data collection or data mining of IoT devices which monitor the data, processing them, comparing them with the existing database information to predict to predict the weather. So depending on all those readings, how different industries work. Some use real-time data, some use data prediction models from the data we obtain from weather monitoring devices, right? So again, next also we talked about how um, same IoT devices can be used in different industries for different purposes, so on and so forth. Then after understanding what is IoT, how IoT is used in local or global, industrial, in different domains, then we looked at introduction to applied IoT. Applied IoT refers to the practical application of Internet of Things technologies and solutions in real world scenarios across various industries and domains. By now, I think you have a complete understanding of how IoT is being uh, applied or IoT is being used in real world scenario. We have gone through plenty of examples. uh, I have even posted all those videos where IoT is used in different domains. How now you by now I think you have understanding of entire infrastructure which is needed to have IoT system. Not only the IoT devices themselves, but to facilitate IoT system, we have learned that there are 4 layers and so on and so forth. Where you have the perception, networking, processing, and application layers, right? So for the coming back to the definition of applied IoT, right? It involves using IoT devices, connectivity, data analytics, and cloud platforms to solve specific challenges, improve process, enhance decision making, and to create value. Yes. So as per this definition, you can see now what we are learning and what we are targeting to learn. We looked at characteristics of IoT or characteristics of IoT systems. So these are general characteristics that you will find in IoT systems. Yes, you will find connectivity, you will find perception, or the hardware layer. So you will find data analytics, you will find automation, you will find scalability, you will find that security is an important topic, real-time communication, heterogeneity, edge computing. So these are features that would be there in a IoT system, right? So these just we looked at them briefly. Then we looked at machine to machine, right? And we looked at examples how they work: smart grids, transportation or logistics, healthcare, smart cities, so on and so forth. We looked at the differences between machine to machine and IoT in different fields, but one of the things that I keep on highlighting is with today's technology, with today's capabilities and technologies, right? M2M, there's the difference uh, of M2M and IoT. The line is getting blurrier and blurry because if somebody asks to build a M2M system today, it will basically look like a IoT system. So that is why we have to understand that with the current technology, right, M2M and IoT, the distance or the differences between them are getting smaller and smaller. Then of course we talked about a little bit about operational technology. Again, another similar to M2M, OT is something, there are another technical term that is being used for the same thing. IIoT is also industrial IoT. IIoT means industrial IoT. That is also a term which is used for the same scenario, right? After understanding that, we first looked into the market perception of IoT. We looked at the growth, the industries, right? Connectivity and devices, data analytics. We looked at different situations in the market itself and how the outcome is positive, right? Then we looked at value chains, right? We know that the market perspective overall is positive, so we then talked about value chains. When coming into value chains, we talked about the different main links that are there, the device, about the devices, about the connectivity, service enablers, IoT applications, managing IoT services, and customer are the main parts of the IoT value chain. Then we understood that different companies are there in this value chain creating value. You can be a company that caters to every part of this value chain, or you can be a company that caters or add value to a specific section of the value chain, right? We looked at the examples which are out there when coming into device manufacturing, connectivity, and so on and so forth. By this point, now you should have a understanding of value creation using IoT. What are the avenues that are there in value creation in IoT, right? You have We talked about the market of IoT has the potential to grow, right? Has the potential to industry adoption, right? We talked about still there are countries, industries which are still waiting to adopt or having plans to adopt IoT, right? If that in that if that was the conclusion we take out of the market perception, right? That means more value IoT value chains are going to be created. If more IoT value chains are going to be created, it's not only about devices, connectivity, service enabler platforms, IoT applications, and managed services are also going to increase with each and every IoT system which is newly being created, right? So in that we looked at a small example we looked at a small example of where these companies come into the specific value chain, how the why does customers need another service management company, IoT service management company or IoT company to provide specific IoT technologies. Maybe mainly it is because that it is their business does not comply with IoT, so it is easier for them to give that particular task or contract um, to creating a IoT value chain for them to a service providing company. After having after looking at the value chains, right? After understanding that value chains are there, and uh, there are more possibilities for IoT systems to be initiated, right? We looked at IoT architecture, right? So basically what we are looking at as IoT architecture is similar to the value chain. We looked at the comparisons of the value chain and the architecture. The normally IoT architecture has a perception layer, transport layer, processing layer, and application layer, and we see that each layer is a link in the value chain itself, right? We talked about these things, how data is being processed, and we talked about cloud platforms, we talked about applications needed, and we talked about the networking. So then we went into our topics that we are looking into right now. It is the main design principles and its capabilities of IoT systems. So what we are looking here is when we are designing IoT systems, when we are looking at perception layer, when we are looking at transport layer, when we are looking at processing layer, when we are looking at application layer, when we are designing them, when we are building them, when we say to a company to build a IoT design, or if somebody tells you as an engineer to build a IoT system, or to draw architecture, come up with a document which defines the architecture of a particular IoT system that provides a solution for an existing problem, right, or to automate processes, right? That particular architecture in each layer should have these properties. Number one is scalability. We talked about it. We talked about how each layer and the scalability works. Now we are on the second topic, interoperability. right? Interoperability basically means the ability to interact with different, if you take the software, the ability to interact with different other softwares. If you take devices, right, we it is interoperability is a, we can say interoperability and scalability goes together, because if we are to have IoT in a way to scale up, right, adding more devices into the systems, adding right, by adding more devices, more data will be created, more networking will be needed. So interoperability as a property helps scalability, right? Having IoT devices that can talk to other IoT devices regardless of the product or the brand, having computing processing systems, data storage systems, data processing algorithms, cloud computing, regardless of the product that is producing that data, right? Like we talked about this in scalability, that is something we need to look at. Then again, networking, same thing, regardless of the brand or the software or the networking capabilities that are there, it should be able to interact with the existing network of the system, right? So interoperability is that property. IoT devices and systems from different vendors should be able to work together smoothly, right? One of the real world examples we talked about is Alexa, right? Amazon gives a product called Alexa, which is normally operated from voice command for smart homes, right? Other IoT devices including smart lights, temperature control systems from TV, from your smart fridge, smart washing machines, your Roomba system, your security system in the home, all these things, right, have the capability of interacting or taking commands with the control device. In this case, it was Alexa. But not every IoT product is manufactured by Amazon. They will be from different companies. So that means the interoperability property is there for, let's say, a smart lighting system to connect, to interact with Alexa, right? So that means necessary codes and everything are being shared between those companies, so that other companies can design IoT products to interact with Alexa, right? Which is a property that is valued in the IoT ecosystem. Interoperability ensures that devices can communicate and exchange data using common protocols and standards, regardless of their manufacturer or technology. If you are to design a IoT system and introduce into the market, now you know the properties that should be there. Interoperability should be there. If your device is to be used for scaling up a IoT system, right? Let's say you design some kind a good contact sensor, right? It works much better and longer than existing systems in the market. But if you do not have um, uh, the necessary standards and protocols embedded in that device software to seamlessly adapt that particular adapt your device instead of other devices to a existing IoT system, the value of your device will be not there in the IoT market, right? Because even though your IoT product is better, existing IoT systems and people who are designing IoT systems would have a set of protocols, standards which have been shared throughout the IoT ecosystem around the world, where it gives a unique capability for IoT devices to be added into any new or old IoT system, right? So when you have a better sensor, a better product for better value, right, you have to always look at the protocols, standards, right, which will help with which will help with compatibility on existing systems, right? Standardization plays a vital role in achieving interoperability. It involves the development and adaptation of common protocols, data formats, communication standards, and interface that enables devices and systems to communicate and understand each other. Standardized organizations and consortia such as Internet Engineering Task Force IETF, Institute of Electrical and Electronic Engineering IEEE, and the International Electronical Commission IEC define and promote standards relevant to IoT. So, number one, it is standards, right? When we talk about standards, how can we build a IoT device up to standard? That means there should be some kind of written set of rules. Okay, these protocols should be there, right? These kind of encryption should be there. The data formats should be like this. You should have the ability to interact with such network protocols, so on and so forth should be there. Where can we find those standards? If so, where are the locations? Internet Engineering Task Force, IEEE. This is one of the most famous standardization organizations for electronic devices, which includes IoT. So, if you are to design IoT system, if you follow the standards of IEEE, that would be the best, and it will be not only nationally, internationally recognized, right? Also, we have IEC as well, right? So, when you are designing your system, standardization, having standard protocols, right, is important. So this is the document which has been produced by IEEE for IoT, right? So in this document they will have different sub documents which they use to give a set of standards, right, for different layers in the in the IoT architecture, right? Um, so you can see here for series on Ethernet, wireless LAN. So here one of the points that you have to understand here is this: if you take a series on wireless LAN or on Ethernet, this is on transport layer, and we talked about that transport layer in general, we are talking about the networking of it. So the same standards which is there on IEEE for networking here, wireless LAN or Ethernet connections, will be applied in the IoT architecture as well. When you are designing a device, those standards go through to them, right? Um, then you have, okay, we have approved standards, ISO standards, IEEE standards for floating point architecture, IEEE standards for signaling methods on bidirectional, parallel, okay, computing standards. So these are all standards which are being used in one way or another. One of the points that have to be stressed here is that um, where does most of these standards come in the value chain, right? We defined about right, we talked about different uh, links in the value chain. We talked about the devices, we talked about networking, we talked about backend storage, processing cloud, so on and so forth. We talked about application layer, we then talked about service providing, and we talked about customer. Where does this applies to? This mainly applies to the people who actually produce the hardware and actually who produce um, who produce the hardware and the software, the developers, the R&D section, right? The research and development section of it. When coming into service providing, you will be taking the devices, you will be taking the software which is already being developed under these standards, and because they are because they are in standards, you are just putting them together to make the entire system, right? Here one of the protocol, one of the things that caught my eye is IEEE standards for service interoperability in Ethernet passive optical networks, right? So you can see that there are set of standards that are there you have to follow through, right? So generally if you take Ethernet, we are talking about networking, right? So this is one set of standards that are there, right? There are ISO standards, then we talked about the other set of standards which are there. What does this do? What does this do mainly? Let's take an example from something we see every day, right? We know about our cellular service providers. That is something given. We know that our cellular service providers, but they use not their antennas, they use different kinds of antennas, right? uh, you may have seen cellular towers everywhere, and these towers are operated by either Arch, Mobitel, Dialog, depending on the service provider. They are being operated, but the hardware itself might come from Huawei, or it might come from Ericsson or other company. But whatever said and done, if one of those antennas break down, a Huawei antenna can be replaced by a Ericsson antenna. The function will not get affected. Why is that? Because both of them are manufactured to a certain standard, right? There are the protocols that are there, the data or the bits that are being uh, the electrical signals which go through their systems are the same. They make it the same, right? Because end of the day, it's a bit that goes through 1 and 0. So uh, uh, simply saying that, okay, those 1s and 2s should go in a pattern where they should understand even the hardware components, right? If they have the same port types and everything, it's just easy to replace and maintain the entire system. Think about your laptops. Your laptop would be Dell, your laptop would be HP, your laptop would be Lenovo, your laptop would be Mac, right? uh, Apple Mac or things like that, or you could have a tablet PC. But if you have a USB drive, and you if each and every device has a USB A port, right, you will be able to plug it in and read it. Why are you able to plug in to a similar port in any device with different manufacturers and are able to read these things? That is because though the manufacturer differs, the standard they use is the same. USB-C is another good example. Those are physical examples. Now, if you go to virtual examples, think of the data formats, right? When we have different types of hard drives which have been manufactured by different types of um, companies. We have different types of people manufacturing processing units, RAMs. There are different kinds of companies which then assembles everything together on top of their motherboards. Dell, HP, Lenovo, so on and so forth. So, but if you transfer data, let's say from a USB, from one PC to another, you will be able to read it. You will be able to read it without any error. What that means is that the standard of the data, right? The standard of the format of that data is equal in each and every device. The software that has been used could be here, it could be Mac, it could be iOS, it could be Windows, Linux, depending on your system of reference. But then again, you have seen that some USBs or external hard drives which you can plug into, let's say, Apple devices, cannot be plugged into Windows devices because of their data formats, right? Then you will say you have to format your device for a like FAT32X where anybody can read. What that means is, when the standards are different between Apple and Windows, when standards are different, the compatibility issues happen. Now you can see little by little how these, so most of the time each and every company around the world where software or hardware try to keep the standards, try to keep the common standards as much as possible, because when we want to scale it up, right, interoperability should be there, right? So that a company which wants to develop a software can be used, uh, can be used in different either laptops or different devices. Same with hardware. If you come to the network layer, it is the same again. Doesn't matter the brand of the switch, if it is Cisco or whatever, right? The standards of IP addresses would be the same. The entire internet itself runs on that particular concept, standardization or interoperability, where standardization is there, so that you and I, when producing a hardware device, or when we are to produce a application, right, or a website, or to produce from a website to an email server, whatever, because we have the standards in place, either we knowingly or unknowingly will be using those standards to build what we want, right? So that is why standards are so important. Now think about office that is going to use Windows devices are going to use Linux or Apple devices. There will be some changes that would be needed to be done, otherwise it is hard to facilitate. So companies which are using Windows devices tend to use more Windows devices because it is easy to facilitate. Now you can see by having that standard built in when you are producing IoT product, it would be better, because people who build IoT infrastructure or IoT systems prefer to have devices which have common standards and can be plugged into their system, right? And vice versa, people who are designing these systems, which is in this case you, right, people who are learning to design these systems, again in which this case you, should concentrate on having general known standards in the IoT application or the IoT system, so that when time comes for expansion or adding new devices with much more better performance, there will be no failures in the system itself. So standards is a property of interoperability. It's a part of interoperability. The interoperability nature helps greatly in scalability as well. Helps scalability as well. By now, I think you have a general understanding of what standardization means, and what are the points that is needed to be looked upon when you are creating a IoT system in general. And one of the points that then we should highlight is that standardization does not end with perception layer. It goes to transport layer, it goes to processing layer, it goes to application layer. As for the past examples, hardware, software, network communication, whatever the layer we are working with, standardization is important so that compatibility will be there for between devices. So the next topic, the next subtopic would be communication protocols. IoT systems rely IoT systems rely on various communication protocols for data exchange. Interoperability can be achieved by selecting widely adopted and standardized protocols such as MQTT or message queuing in telemetry transport, CoAP, constrained application protocol, or HTTP or HTTPS, Hypertext Transfer Protocol, and WebStop. These protocols ensure that devices and application can communicate with each other regardless of their underlying technologies. Yes. So as I told you before, right, um, all layers would have the ability to communicate between each other, and that is mostly achieved by standardization. If you look at the first example we took Amazon Alexa product, right? So whatever the application, whatever the other device which is being paired with uh, Alexa, right, in a smart home system, that pairing of those devices happen because of the standardized use of standard protocol, right? That means that each protocol in each device matches so that they can communicate. Same here, whatever the input that we give in the application layer. So when we talk about the application layer, we not only talk about actuators which give us information, right? We actuators that give us information would be speakers, would be screens, would be LED lights, so on and so forth. But also there are a set of sensors there in the application layer for inputs, right? If you take capacitive screens or touch screens, that means that not only it can display information for us, it can take commands or inputs from us. Mics are there. If you take the example we are mostly concentrating on here is Alexa, so it get commands through voice. So that means that that particular layer should have communication all the way up to uh, the perception layer. In that sense, right, protocols should match between the devices and the application layer. So this is what they are highlighting, right? When we have in the process layer, when we degenerate information, we have to show them, and if we are giving feedback or input from user perspective to the process layer, right, the communication have to be carried out. Simply another simple way to put this is that uh, the same protocols or same techniques or uh, same standards when creating a web application or a general um, app in users to use in mobile phones in such scenarios, right? You can use these standards to communicate. So the same standards that are being used in web applications, websites, um, applications are being used here as well, because when we want to when the application layer wants to communicate with the perception layer, the message should go through processing layer and transport layer into the perception layer, right? So in that sense, right, there is always the traveling is linear, and it doesn't skip in between. So in that sense, right, the first communication will be happening between processing layer and application layer, which is back end and front end of it. So that means it is basically acting as a application. Next, point is that data formats and models. Interoperability requires consistent data formats and models for effective data exchange and interpretation. Technologies such as JSON, JavaScript Object Nation, and XML, Extensible Markup Language, provides flexible and standard data uh, res- uh, representation that can be easily understood and processed by different systems. Additionally, semantic web technologies including RDF, resource description framework, and ontologies uh, uh, enable machine reliable and semantically rich data representation, enhancing interoperability. So right now, as you can understand, when we talk when we talk through each when we talk to data formats, when we talk to communications, if you have learned about application development, app, if you learned about application development or the entire application development life cycle, you will understand that these are points that is been addressed in that level as well, right? So before we talked about generally, right, perception layer is the layer that is unique to IoT, while transport layer is basically networking infrastructure, and we are talking about networking, right? There will be some additional parts of having networks which are dedicated to IoT, but other than that, it would be the same. Processing layer and application layer is basically the same layers that you can find in the application development world, where we talk about back-end programming and front-end programming, right? So data formats similar to communication protocols will be the same and will be using the same standards. API, Application Programming Interface Design. APIs plays a crucial role in enabling interoperability by providing well-defined interfaces and methods for accessing and interacting with IoT devices and services. Using standardized API design patterns such as REST, representational state transfer, facilitate interoperability and allows applications to communicate with diverse devices and services using common set of protocols. A general example or a general definition of API is API is the middleman or the bridge which two different programs are using to communicate between each other, right? API, that would be the most primal definition, right? The APIs facilitate communication between two applications, right? So you can take a front end of application and a back end of application, right? These two, they are different programs, two computer programs which are different, and the bridge between them is held by the API. So I have some small diagram to show how that works, right? So here the application that you see in the browser, right? The request and the responses go to the internet. Here in the internet, right? Now let's turn this into IoT perspective, right? So in the IoT perspective, this is the application layer, right? And okay, this would be the application layer. This, though we don't talk about it much, right? This is also the transport layer. The internet itself is the transport layer. This, both of these, right? The storage and the servers would be the processing layer. This would be the transport layer, and this would be the application layer. Now you can see where APIs are situated. They are situated between the transport layer, between two computer programs. Here it's the front end software, right? The front end applications and the back end applications of the software, right? This helps to communicate between those frameworks. Now, if you think about it, right, this example here is mostly towards application development, right? You can see that is mainly towards application development. But if you talk about IoT goes a step further from application development. So what does that mean is, there's going to be in between, if you talk about the layers we have here, so we are talking about these three layers right now. But there's the perception layer. So how does that look like, right? And how APIs may fulfill a role, right? So from this, right, if you take this as one set of layer, this is the processing layer, right? That means from processing layer to the if you are going into the perception layer, there's going to be another transport layer available, right? So there's going to be another transport layer here between the perception layer, communicating between the perception layer and the communicating between the perception layer and the processing layer. There should be in between a transport layer, and finally in the end you will find the perception layer. For now we will define the perception layer from this box, just for, right, let's say perception layer. So that means are the computer programs which is in process layer, where to store the data to and the web services, can they speak to these hardware devices? So there should be some kind of a set of applications which are, or computer programs which are dedicated for these IoT hardware devices, right? So that means that there should be another API, right, which would be taking place in between transport layer from the transport layer to the perception layer to carry out communications. I hope that makes sense, right? To communicate if the perception layer wants to communicate with the processing layer, there will be APIs available. So in the middle it would be the processing layer, right? In IoT it will talk to both sides, so a double copy of this will be there, a mirrored copy of this will be there. This side it goes to the application where the user can see and interact with the device, and it will go through this side to the where the device interacts with the user itself. So APIs for software development, there's a lot, right? Twitter bot, Google Maps have their own APIs, so on and so forth. There are few APIs that are famous for, right? Your general booking sites, booking for tickets or booking for planes or booking for hotels, you will have APIs for doing sales. You know, if you study about platforms like Spotify, you will then understand how these APIs work, right? They will be the middle ground for your sales platform and so on and so forth. And we talked about how these information are, so how does other programs, computer programs, other devices, IoT devices talk to Alexa through this Alexa development tools and skill management APIs, right? This is the in the website you can take the information need so that you can program your IoT device to communicate with Alexa. This one over here is for Arduino Cloud. For Arduino devices to connect and communicate with the cloud, this is the Arduino IoT Cloud API which they have in their website. Similarly, we have writing data from Raspberry Pi using OAS REST API. Right? This is a knowledge article that was there. So you can see that all IoT devices, not all IoT devices, well, yes, basically if we are to connect to the internet and if we are to connect to the cloud, in the IoT infrastructure, similar to application development, right? End of the day, if you take out everything that is here, right, and just if we have something like this, right, just let's concentrate on this for a moment, right? And if we have only this particular right, let's concentrate on this for a moment. So this is how APIs work for software. It will start, there will be databases connected to servers, and those are communicating to the web app in the browser, which will be hosted in a hardware device itself through the internet. Similarly, at the end, at the corner, there will be hardware devices in IoT where they will be connected to the internet. So that means they have to use APIs as well to communicate with web servers. So this applies to the other way around. This is what I want to show you, that APIs are being used when we are creating a IoT device that can be connected to the cloud. There will be the use of APIs. Why? Again, so that it will have the ability to communicate between cloud services through the internet, right? When they are able to, when the IoT devices are able to communicate to the cloud services, then the cloud services will use another set of APIs to communicate with web applications and browsers, so the users can see the results, right? These results will be shown as a as the process layer, where databases and servers will use APIs to communicate with your web browser. Users will see this, and if a user inputs some data into this calibrations or some kind of settings, right, configurations, that means that information should go through the internet, through the API to the web server, and the server will update through the internet, through the API to the perception layer where the IoT device is there, right? I hope that this part, so it is not, this is some use of APIs is there to communicate between two different programs. That is the most easiest way to understand. So you know that web applications have different programming. Servers and data storage, they have their own set of programming, right? Then if you talk about if you talk about IoT devices, right, they have their own programming. So each program is not compatible with each other. So that means there should be a middleman to to translate these data to a understandable form, and APIs are the ones that do that, right? So in interoperability, APIs play a very crucial role. So for the last few topics, right, standardization, communication protocols, data formats, we are all talking about standardized options. Here in API, we are talking about programs supporting we are talking about a program or a unit that is used to support or to act as a bridge between two different computer programs, right? Which will help again to have a, which will then again interoperability is confirmed through this, right? Because if the device, let's say if we build a IoT device that cannot be connected to the cloud itself, how are the users going to interact, with what is the application that is going to be used? So all these problems will be there. Again, similar to scalability, interoperability is also important when placing your product in the IoT market. Next is device integration. IoT systems consist of devices from different vendors, right? Different vendors means different companies, right? Different brands, each with their own protocols and the interfaces, right? Interoperability can be achieved through the use of gateway devices or middleware that can translate and bridge the communication between devices with different protocols. These devices act as intermediaries, enabling seamless integration and communication between devices that would be otherwise incompatible. Okay, so from this device integration, what we are talking, so let's quickly look at what we are going to talk about, right? The best example that we can give here is gateway devices, right? And middleware, translate, bridges, so on and so forth. So best example here is that we talked about when talking about IoT devices and IoT systems, they tend to use a set of communication protocols that are unique to IoT devices. Why they mostly use that is because of number one, not to saturate networks which are normally used by humans for other users, such as Wi-Fi, right, Ethernet connectivities and so on, right? Not to saturate them, because if there is a set of edge computing that can be done inside the devices or inside the IoT system itself, it can carry out, and the communication can be done internally inside the IoT system itself. So to carry out those, and also these devices, some of these devices would need to preserve energy, especially ones that works with batteries, right? So to make it energy efficient as well, we use protocols such as Sigfox, Z-Wave, Zigbee, as communication protocols, right, as wireless communication protocols in IoT systems, right? But if you take Zigbee, Z-Wave, Sigfox, LoRaWAN and things like that, and when you compare the protocols and when you compare the frequencies that they use, the protocols that they use, and so on and so forth, you will understand that they don't have the ability to use general Ethernet, fiber optic, or Wi-Fi technologies. They don't have the ability to communicate with them. So if we are to connect our IoT systems to the cloud, we cannot use Zigbee, Z-Wave, or things like that, which are dedicated protocols for IoT, to communicate with the cloud itself. To facilitate that communication or the transition from the IoT devices, right, to the internet, or to the cloud, to communicate with the cloud itself, we use gateway devices, where these gateway devices have the ability to understand IoT based protocols, right, and convert them into general networking protocols that can be understood by the internet itself. So that is what a gateway does, right? Think about having 150 security cameras, having in 500 smoke detectors, right, contact sensors and so on and so on in a IoT system inside a 50-story building, right? And most of the things are handled by edge computing, but some of the data needs to be gone as stored in a cloud server. So, but nobody wants to saturate the existing network of the building with the communications of IoT devices. So the IoT devices would be programmed in their separate own protocols, in their own separate frequencies. So they will have a dedicated IoT network for them to work without any delay or packet loss or any network issues while not interfering with the existing network of the building. But when they want to connect to the internet through the existing network of the building, they have to use devices such as shown here, gateway devices, where they can understand which is the protocols such as Zigbee, Z-Wave, and LoRaWAN, things like that, which is dedicated to IoT, and they will convert them into uh, either normal standardized protocols used in internet communication, so that they can communicate with the cloud. So that example is simply that, right? Interoperability is achieved by such gateways which we can use when developing IoT systems. Interoperability testing and certification. Interoperability testing ensures that devices, protocols, and applications adhere to the defined standards and can uh, interoperate efficiently. Testing and certification programs help validate compliance with interoperability requirements, fostering trust and confidence among vendors and users. Yes, so these are also what does this means is the final audits when of audits and final certifications to show that yes, you have used standardized protocols, right? If you are to IEEE standards, or if you are to build a IoT system to IEC standards, right? You have to show the customer that you have done it in that particular standards, right? For that, audits and testing should be carried out. So this is so from this topic that it is to show, right? It is to show to the customer that yes, we are up to that standards, which means that we have the qualities, you know, the interoperability is there. We can scale up, we can use different devices when needed. We can if a new better product comes for a security camera or a better sensor comes into the market, if we want to adapt that sensor, we can adapt that sensor into our systems because we are under these standards, right? So any company which makes their product to that particular standards, we have the ability, we have the gateways, we have the protocols to and we follow the standards to adapt those things into it. It is very important for the customer, right, to have certification of these things. Of course, if you search for these certifications, you will find them in the there are companies that carries out these audits, and to see those standards are there, you can do it by third party or internal means. The important this is mainly to for the customer in industrial scale, right? Most of the things that we talk about in applied IoT is in industrial scale. Um if you talk about smart homes or small solutions like that, it is it is not that much considered these certifications or abilities. But if you take a company which let's say uh, we are going to build a smart electricity grid, and we are going to have sensors all around the country to keep a track on the electricity distribution system, to see the health of the electricity distribution system in the country. So if the user wants to buy a product, IoT system, to do that, right? We have to show them that we have the ability to upgrade whenever necessary, to show that we should show this certification, because if they are up to standards, that means upgrades can be done. Here, as an IoT engineer or a person who is knowledgeable about IoT or applied IoT, you can be in the both sides of the negotiation table, right? You can be on the side of the customer or the service provider. For example, if you are the service provider, you will make sure that all the other components that you buy from other uh, vendors are up to standards, and your entire system that you are presenting to the customer is up to standards, and you will show the certifications. Again, you will be on the other side of the negotiation table as well. You will be on the customer side as a consultant to see if that the product is good. So one of the things that you have to check is that if the IoT system, they are showing you the IoT system, how we can do this, and these are so these are the sensors that we are going to use, so on and so forth. The next question that you should ask is, are they up to standards, and at least up to IEEE standards, and protocols will be there. Because if in large scale applications such as electricity grids, right, where thousands and thousands of IoT devices are there, and if some upgrade or update or something is needed to be done and you cannot do it because they are not up to standard, or um, the service provider would just use their standards so that we can move to other devices, things like that, right? That would financially devastate the customer in the long run, right? So then if you are a consultant of the customer, you should check also whether the interoperability testing and certification is there as well. Next is the schematics interoperability. In addition to schematic interoperability, matching protocols and data formats, um, sorry, uh, in addition to synthetic interoperability, matching protocols and data formats, which we talked in before, semantic interoperability, he aims to achieve a common understanding of the exchanged data and its meaning. This involves using semantic technologies such as ontologies and metadata to enable data integration and semantic reasoning across diverse IoT systems. What this basically means is that the ability to connect the IoT systems or the data which has been generated through IoT systems to either advanced language models, advanced image models, basically, or advanced algorithms in data processing, big data mining, and AI, right? So semantic reasoning today, we know it as AI technology. So basically, compatibility with AI, we can say as a summarization of what is meant by semantic interoperability. Why this is important? Let's look at few examples why these high-end language models or AI capabilities or prediction models, probability models, which is used for data mining, big data processing, so on and so forth, is important. right? Why these metadata points are important, right? Um, so for example, we remember, if you remember lecture number 7, where we have the examples of different IoT devices to understand what are IoT devices. In that, you may have seen the example of logistics, using IoT devices in logistics, right? So you have the legacy system where you have the delivery truck, where you can deliver the logistical goods through, and uh, they have introduced the IoT device which has the capability of analyzing the location, the speed, the temperature inside the vehicle, so that the goods get to see the goods get damaged or not. If the condition of the road, how much vibrations are there, so on and so forth. So, what can be the outcome of it? We are collecting all these data points and metadata points, which are very, uh, if you look at it from above, those are very simple points. Information about, like, if there is a lot of vibration in a road, we can think of the road quality is not good. If there is a lot of traffic in the road, we know that the logistical, there will be a backlog, because there will be, you would need more time for the goods to travel. So why do we, and if, like, let's say, depend checking the temperature inside the containers themselves, right? It could be different in the summer, it could be different in the winter, and they may affect the goods inside, if especially if they are like food materials inside. So that may also affect, because now, why that amount of data and integration with AI models are important. AI models have this ability, which has gone uh, beyond predictive probability models. Like, for example, normally, if you put the, if you put your Google Maps and start, um, give some locations for it, right? You will see that it will optimize the most closest path to it, right? So that is done through probability models, looking at the traffic which is there, and which roads are open, which roads are closed, and it will give the quickest or couple of options which you can reach the point safely at a given time period. They will give an estimation of time. So those predictions are done through probability calculations, right? So you would need different metadata points from, to check the, uh, to check if there is traffic on that road. You need metadata from people who are using Google Maps on that road already, right? Those data points should be taken in and calculated. So AI learning models take this to the next step, right? Predictions can be done in ways that even probability, sometimes probability models cannot do. Uh, so back to our example, we were talking about the logistical information. So if we have a probability model or AI model, whatever, if we have the metadata of all the logistical trucks that are traveling on that road or a particular route, or, right, there are like 4 ways to go from A to B. But if you are carrying some equipment, it could be heavy equipment, it could be fragile equipment, electronical goods or glass materials, so on and so forth. What would be the optimum path? If you are carrying some very fragile material such as glass, or uh, if right, if you are carrying TVs or things like that, right? a AI model can predict the best, depending on the material you carry, the closest path maybe not the best path, because there are a lot of vibrations taking place in that road due to the quality of the degradation of that the quality of the road. So what would be, so maybe the longest distance would be the most productive, the longest path would be the most productive method of transporting that goods, right? Because the probability of getting goods damaged in that path, though it will take some time, though it's a little bit far, but the roads are good. So end of the day, if you are transporting, let's say, 100 metric tons of this fragile material, and going through the closest road had a 10% chance of breaking them down, and going through the predicted road through AI is 1%, that 9% will actually help in millions of dollars, right, when coming into large scale logistics. Similarly, AI models even can predict, like, okay, you have a fleet of trucks to transport it from here to here, but what about, because these are heavy loads, why don't you use railway to go from distance A to B, and from B to C you can use trucks. So to make those unique predictions through AI models and so on and so forth, the amount of data which is being generated, including the metadata which is being generated through IoT devices, are important. So semantic interoperability means that these data can be used by for uh, programs which have cognitive reasoning, basically having the ability to use them in big data models, right, in big data, AI, and so on and so forth. Then it is ecosystem collaboration. Interoperability is a collective effort that requires collaboration among stakeholders, including device manufacturers, software developers, standardization, optimization, and industrial alliance. Collaborative initiatives, open source projects, and partnerships encourage the development of and adaptation of interoperable solutions, uh, fostering a vibrant IoT ecosystem. Yes. So again, you can we will first start from IoT systems. We talked about value chains, we talked about how all these different service providers have to have standards, and the service provider have to check those standards and put them all together, so that each and everyone can communicate, so each and every layer can communicate between each other without any error, right? Similarly, we talked about when we talk about the IoT ecosystem, right, the very first example that we talked about comes into mind, right? Here you have a smart city IoT system which relies on weather IoT devices that monitor the weather. So this could be a different IoT system which would have their own application, their own database, right? It would be a company, and that company will be selling data for other IoT systems that require it. But if the data which they sell is not compatible with other IoT specifications or IoT systems, they can't use that data to a great effect. So that is why interoperability does not end from a single IoT system, right? This is a concept, like this is a main concept of IoT. So if you are to build a IoT system, and some of the work which is being done is already there by already there's a IoT system which carries out that particular function, in this case monitoring the weather. You don't need to build that system into your system. You can get the data from those IoT devices, talk to those IoT devices and get the data through the internet for your IoT systems to work, right? So that is how an ecosystem is being built, right? The concept of IoT have this property, right? So if you are to build a value chain, right, including devices, connectivities, service enabler platforms, IoT applications, managed services towards the customer. Another point that you have to understand is you can add value to your IoT value chain from other IoT value chain. In that, so if you are to get some information from another IoT system, you will be the customer of that IoT system's value chain, right? So it goes full circle. So you will be the customer, you will be taking that data from a different IoT value chain, then you will be adding your devices, connectivity, back end, front end, and your service providing to another customer. So now you can see why the ecosystem is important. So the interoperability of data and devices are important, because IoT has that particular property as a concept from the beginning to use, because it's Internet of Things, right? Each thing has the capability to connect with the other thing. So that means if there is already an existing system or existing IoT system or existing sensor device or actuator device which can already carry out that particular work, if there's a sensor that can already get the data you want, you don't need to build that sensor again, or you don't need to buy that to invest in another sensor, because that data is already available, right? So if ecosystem collaboration is a fundamental thing which comes with interoperability. So we are talking about scalability to interoperability. These are properties that are there in IoT systems, right, in the architecture, which is defined as these 4 layers. In that architecture, right, in that system, these properties should be there, these standards would be there, right? Then the next one is security. The next main topic is security. So this would be also a characteristic that would be there in the IoT system that you are going to create. So before talking about security, what you have to understand is these are commonly shared design principles in IoT system, right? That is one of the points that I think I should highlight here. is that these are commonly shared principles. Your IoT system may look may be used for security, may be used for healthcare, may be used for monitoring the electricity grid, may be used for weather monitoring, or so on and so forth. The design will be fulfilling some kind of application in some kind of a domain, but all these systems, IoT systems, should have these capabilities or design principles in it, right? So that is what we are looking at. Additional fact for this would be, you must be thinking, okay, if I get to know these things, where should my position would be? If you are a IoT project manager, you should know that, you should know these things, right? And you should know that your IoT project is up to standards, right? Scalability is there, interoperability is there, the certifications are there, the security is there, so on and so forth. You should know that. If you are a service provider, you should know that these things should be there from each and every point. If you are working in the customer, now if you think, we talked about apparel company, right? So in an apparel company, they will get the IoT system from a IoT service provider, because they don't have the capacity or the technology to build a IoT value chain for themselves. It is much more cheaper and easier for get the expert knowledge from a company which already have IoT value chain and dedicated staff to maintain that. But in the customer side, there will be an engineer, there will be a service owner, right? There will be a managerial position which is known as a service owner, or for applications there's a position called application owner. For servers, there are server owners. So for different things, there will be a person, a manager, who will be in charge from the customer side. If you are to step into such a position, right, in your career, then you should know the qualities and principles that you should have in your IoT system, because the service, the IoT device manufacturers, service provider, so service provider in general would give the product, okay, this is our IoT system, right, and will give the documentation. You should have the ability to go through the documentation and understand whether this is a good IoT system or not. So the first thing that you will be looking for in that, right, the service provider will be fulfilling your value chain needs, right? The first thing that you will be looking for comes in the definition of IoT, applied IoT, right? In the definition of applied IoT, right, the devices connectivity, we call to solve a specific challenge, improves process, enhance decision making, and create value, right? So creating value happens through the value chain itself, but your company might have a problem that is needed to be solved through IoT. So the first thing that you should, if you are representing the customer, right, and you are on the service manager position, the first thing you should see is that does the uh, IoT solution which is given by the service provider fulfill your requirements? Does it solve the problem? Does it automate the system? Does it provide information that is needed for decision making, right? Does it improve processes, so on and so forth, right? Does it fulfill your requirements? The next step would be to check whether the IoT architecture or the IoT system that they are giving as a solution would have the common design principles, which would be scalability. If I want to open another new apparel factory, can I use this system and make it use the same system in the other apparel company? Can I input more devices into it? Can I have, will there be any complications? Will there be error? So we have to check the scalability is possible. We have to check the interoperability is there, the standards are there or not, right? So that if a new product comes to the market or a new sensor comes to the market and that can do a better job, then we have to, if we are to adapt that particular sensor, can we do it? For that it should be up on a certain standard. So, then now we are going to talk about security, right, and reliability and those properties which also you need to check as the service owner in the customer. This is going in a tangent a little bit because I want to tell you why are we learning applied IoT and what are the areas that we are covering, right? If you are the service provider, you should also know that your product should fulfill these things, because end of the day, right, if you are to provide solutions to, let's say, the electricity board, where it covers, the IoT system covers the entire country, we are talking about millions of, not only rupees, maybe millions of dollars per month. And if any failure to understand the requirements and the capabilities of the IoT system, right, will result, if you are the service provider, it will result in unable to provide the proper services. You will not only lose your job, the company will lose millions of dollars. If you are the customer and was not able to understand that these properties are fulfilled, end of the day you will lose millions of dollars including your job. So this is mostly in not the technical basis but a step above. This is not the product development life cycle, this is a step above, right, where implementation of a whole system is there, right? Of course you won't be starting from that particular point in your career. You will be starting maybe as a engineer, developing devices or networks or so on and so forth, but you know now that if you get lucky and if you are thrown into a project where you have to design an entire IoT system, you will know what are the characteristics that should be there, or the design principles that should be there on an IoT system. You would know the architecture, so you can divide it beautifully into 4 pieces and address each level, right, step by step, right? What are the requirements, what are the devices, so on and so forth, right? Then you can see that if all these properties are also there on the system itself, right? A little bit of a tangent, but I think that part is important to understanding applied IoT. Now we can go and talk about security. Security is a critical aspect of IoT design. Devices, networks, and data must be protected from unauthorized access, tampering, and data breaches. Robust security measures include encryption, authentication, access control, and secure communication protocols should be implemented to ensure the integrity and confidentiality of IoT systems. Yes. So, security in a product, right, is very important, and it is needed, right? Let's go for the one of the most famous examples that are there that we can see from our own eyes is WhatsApp, right? Today in WhatsApp you can see that when you have a call on WhatsApp or when you send messages through WhatsApp, you will see a message that shows now that they have end-to-end encryption. The reason for that, for them to put that message was some time back, actually a long time back, uh, people or users found out that these messages are not encrypted, and anybody who is tapping onto their phones or to their communication systems along the uh, pathway inside the servers or in the network actually can take out the data and just read the information because there is no encryption. So that was a big blow to WhatsApp. So they quickly moved to make end-to-end encryption, and today they promote it. Of course, we don't like to, we don't like uh, humans in general like to have their personal communications to themselves. So this, but not only humans, corporations also like to have security over their information, because end of the day vital information should be secured. If they are manipulated, then there will be consequences. Additionally, if information of accounting and those financial information of a multinational company goes out, it would harmfully affect in the stock markets themselves, right? So those information must be secure. Not only that, there are payment facilities that are going on. So security is a very important topic. How does it affect IoT? So the one of the biggest problems that IoT face when coming into security is that IoT, there are in the ecosystem of IoT, we are talking about thousands and thousands of devices, and each and every one of those devices are connected to a network where end of the day have access to the internet itself. So that depending on the use, right, some depending on the application, security is one of the main important things in a IoT system. Because when we talk about hundreds of applications talking to each other in a network, the ability to hack into the system becomes pretty easy, because vulnerability points will be created through through hardware devices which have less monitoring power, less processing power, and less secure than laptops or smartphones, right? So that is one of those points. If you take a smart if you take a smart smoke detection system, right, the capability of that having encryption and all the processing power necessary to secure the data which it sends is pretty low. So those things create vulnerability points. But think about if you are providing smoke alarms to a defense facility, NASA, or a oil refinery, which is end of the day is vital for the economy of the world, right? Nuclear power plants, right? Those are places where even those small vulnerability points should be not there. So again, don't think about only your house, right? Security in IoT systems are really important because we are talking about industrial scale. So the impact of it, right? If a smart home security system could be hacked into, 4 or 5 people will be affected. But if the IoT system in a nuclear power plant is affected, we are talking about millions of people being affected. So now you can understand the impact. Now let's get on to the features that should be there in IoT systems for security. First point when coming into security is authentication and access control. Strong authentication mechanisms should be implemented to ensure that only authorized devices and users can access the IoT system. This includes techniques such as secure login credentials, multi-factor authentication, and digital certificates. Access control policies should be defined to enforce proper authentication levels and restrict access to sensitive data and functionalities. So here it is clear that uh, there are a couple of different security points that we are talking about over here, right? Number one is that users that have access to the control panel and for the controlling systems, and users who have admin rights to do configurations of those devices and so on and so forth. So they should have a double authentication and right, their login credentials, secure login credentials, separate login credentials if they have privilege credentials on it. So those are normally, we know that when we talk about IT security, right, those are practices that is normally being carried out, and from the user side those practices should be carried out in a IoT system. On top of that, we have digital certificates or digital certificate authentication, as well as device um, device registration, right? So this is mainly because if we have a system to register these devices and give digital certificates to each and every device through the protocols, right, then the IoT system would know what are authentic devices and not. Then encryption will be also easy through digital certification. So end of the day, having protocols like that, right, only having the ability to communicate with registered or identifiable devices, or devices which have been getting security updates, right? If devices are not up to date properly or things like that, then they can also be taken out from the system as well. So things like that. It is similar to IT device management, right? These are also hardware devices, but end of the day, they will be access points to the um, IoT system, through the IoT system to the entire IT infrastructure, including servers, cloud computing, so on and so forth. So therefore, vulnerability points should be reduced. So couple of method. First and the most famous method is authentication and access control. People who have access to those devices and the authentication of devices themselves, so they can log into the system securely, or to see if any attempts from foreign devices to logging into the system take place, so that they can be blocked. Then data encryption. Data encryption techniques should be employed to protect the confidentiality and integrity of data transmitted over IoT networks. This includes encryption of data at rest, stored and device or servers, and data in transit during communication. Robust encryption algorithms and protocols such as SSL, TLS should be used to prevent eavesdropping and tampering of data. So this is the example I was talking about, WhatsApp. Think about these. So think about in a hospital, right? You use plenty of IoT devices. We have gone through many examples. So those data have to be confidential. Nobody should be able to tap from the middle and take those data. Even if they take those data, they should not be able to read them. So that is why encryption is necessary. Not only that, when you have security systems, alarm systems, right? And again, when coming into usage of IoT in sensitive domains such as nuclear power plants, hydro power plants, large scale industries, or defense industry, so on and so forth, encryption is a must have, so that it would add a protection layer to the data which is being transmitted from IoT devices and to IoT devices, as well as of course cloud storage and those things go under normal even under normal IT protocol have to be encrypted and be secured. Then secure communications. IoT devices should communicate securely over the network to prevent unauthorized interceptions and tampering. Secure communication protocols such as MQTT with TLS SSL should be used to establish encrypted and authenticated connections between devices and IoT platforms. Data integrity checks such as message signing or digital signatures can be employed to verify the integrity of transmitted data. Yes. So again, depending on the security needs, we can see by using MQTT or SSL encryption, or we can actually, by giving a signature, a digital signature to the communication sent from the user to the IoT device and from the IoT device to the user. So communication between all four layers, right? We can see if any of the data is being tampered with or being checked in the middle, or right, by having a signature. So that again, that would be a additional step for security. I will repeat what I said before again, especially in sensitive domains which need privacy, which need security. These things are normally a high priority. So depending on the requirement of the user, right? As if you are the IoT system designer, right? If you are the IoT architect for this, It's up to you to add these protocols to secure the entire system. Next point, device and uh, firmware security. IoT device should be designed with security in mind, including secure boot processors, tampering resistant hardware, and secure firmware updates. Implementing secure coding practices such as following the principles of least privilege and avoid common vulnerabilities help mitigate the risk of software based attacks on devices. Yes. So, one of the points that I was telling before is that IoT devices sometimes are not the most secure because uh, some of the devices are, of course, sensitive and maybe large in scale, in processing power, so forth, so on and so forth. The others actually does a simple task. For example, a smart light switches on, switches off, maybe increase the brightness or the colors. If you take a smart plug, it would switch on, switch off, maybe monitor the amount of electricity that is being consumed. A simple temperature monitoring tool would just take the readings of the temperature themselves. So that means that these are some of this firmware is so simply built, right? Uh, so it's basically tamper resistant hardware might not be found in those devices. Uh, Secure boot processors or firmware updates that like heavy duty firmware updates, it's for security might not be there. So then in that particular sense, again, depending on the customer requirement, then you have to make your IoT device in such a way that they are secure, right? Because if you uh, the best example is the defense industry, right? Defense industry, then there's aviation industry, there are other major industries which are sensitive in nature, where different countries want to know what other countries are doing, right? In that particular sense, monetary options or um, investment, the money is not a problem over security. Therefore, when when a military institution or some aviation or sensitive subjects such as let's say like the NASA or uh, any other facility that is doing high technology or companies that are uh, digging mineral products uh, which are very rare earth minerals, or mining companies that mine those things, or electricity grids that have the like power an entire nation, water supply of an entire nation, so things like that, right? They would rather spend more money for security and protecting the system rather than their system being shut down, right? So therefore, depending on the customer, right, even the smallest sensor would require tamper resistant hardware and firmware updates, the regular firmware updates, to keep the security of the device themselves, right? Because as I told you, these small sensory devices sometimes, which are cheap in nature, would not have the capabilities to, uh, they will be a vulnerability point in the IoT system itself. So depending on the customer requirement, it is important uh, to give them the product with the necessary security specifications they are looking for. Next point is secure over the air updates. Okay, so we will for today, right, for this lecture we will stop from here because we have reached our 2 hour mark, right? But there are a set of things that we need to cover along the way, because there are few this particular topic, it has a lot of theory and it's a little bit long, right? So we need to cover these parts. So from the next lesson also we will continue from where we stopped, right? We will try to as much as possible we will try to cover most of the parts that are there. For now we have already covered 2 hours, so we will pause our lecture from here, and I will see you in the next lecture. Thank you everyone. Have a great day.